No, there it is. Okay, so we're going to go ahead and work with these identities again and prove these identities. And there appears to be in this particular problem no connection. I mean, you got tangent and cotangent and then secant and cosecant on one side. You're adding on one side and you're multiplying on the other. So if it looks like there's nothing you can do that's obvious, probably one thing you might want to consider is rewriting in terms of sine and cosine. So if we do that, probably the more complicated side would be the side where you add, but so we'll work on that side first. You could probably work on the other side and get there, but we'll start with the addition. So if I rewrite the tangent as sine x over cosine x plus cosine x over sine x. Now I have two fractions. If I'm going to add fractions, what do I have to have? A common denominator. What is this common denominator? Cosine x sine x. So we know we're going to have cosine x sine x is my common denominator. Now the first term, to get this denominator to look like the new denominator, I have to multiply the top and the bottom by what? Sine x. So this becomes sine squared x. And over here, to get this denominator equal to the new denominator, I have to multiply top and bottom by cosine x. So this becomes cosine squared x. What happens now? 1 over cosine x sine x. And both of these functions have reciprocal functions, which are 1 over cosine is secant x cosecant x. And that's exactly what I wanted. Okay, here's another problem. Well, which one would you, I mean, which side looks a little more complicated, if either? Right. Okay, to me, the right side looks a little bit more complicated. And so, in looking at the right side, Tim, do you see anything that we might be able to do here?
Multiply the top and bottom by its conjugate.
Okay, and what is the conjugate?
1 plus sine x.
Good. So we have cosine x over 1 minus sine x, and we're going to multiply the top and the bottom by 1 plus the sine of x. Okay, so in the denominator, what do we get? 1 minus sine squared x. And we'll go ahead and say we have cosine x. We can multiply that through plus cosine x sine x. You might not need to do it right at this juncture, but we'll go ahead and do it. All right. So, Miguel, what is 1 minus sine squared x? Which one? Cosine squared. Okay, so we have, in fact, I should not have multiplied this through. Let's go ahead and take it back out. If I take it out, Kelly, what can I do now? If I had not, I should have just left it separate at that second step instead of multiplying through. So what, Kelly, what happens now? What can I do?
Can the cosine on the top and the bottom cancel out?
Okay, this,
Get cosine and x on the bottom.
correct. Good. So the cosine on top cancels with one of the cosines on the bottom. So we have 1 plus sine x over cosine x. Okay. You always want to think about where it is you're trying to go. So what could be the next step? What would be a good maybe next step, Colleen? Separating. So how would I separate them?
You do 1 over cosine x plus sine over cosine x.
Good. 1 over cosine x plus sine x over cosine x. Now can those be simplified?
Yes.
To what?
Secant x plus tangent x.
Secant x plus tangent x. All right. Now this is a problem where it looks like one side is probably no easier than the other. So we may have to work on both sides. We may not, but you can just start on one side and see what happens. So, Stephen, any suggestions on where we might want to start here? Left side? Or right side? Which one, Stephen? Okay. So if we start on the right side, what do you think we might want to do?
Is it similar to what we did in the last time? I said left side.
You could. So, Corbin, you got any suggestions?
Well, I don't know if it helps multiply by the conjugate.
Of what?
So cosine over cosine.
Okay, so multiplied by the conjugate of which part? The top or the bottom? Okay, and what would that conjugate be?
1 minus cosine over 1 minus cosine.
Well, this is already minus.
Okay, so multiply by cosine over cosine.
Okay, we'll try what Corbin suggested.
Maybe we should.
1 plus cosine theta. Okay, so if we multiply the numerator, what do we get? One minus cosine squared theta, and I'll go ahead and leave it this way for right now. What is 1 minus cosine squared theta, Chris? Sine squared theta over cosine times 1 plus cosine theta. And you could here, we've got a sine theta over cosine theta, which is what? I don't know if this will do us any good, but we can try this tangent. So we could change this to a sine theta tangent theta over 1 plus cosine theta. I mean, we'll see what happens. We may have to go back and start over, but we'll see what happens. Now that looks like that's about as far as I can simplify on this side. So let's go back to the left side and see what we can do there. What would you suggest on the left side, Adam?
Change the tangent, the sine over cosine, change secant to 1 over cosine.
Okay, we can try that. So we have sine squared over cosine squared over 1 plus 1 over cosine theta. Okay. Now what? Well, you said keep it, change it, flip it. What did we, yes?
Rewrite 1 as cosine theta over cosine theta.
Okay, we can do that. All right, so now we have a complex fraction, and now we do the keep it, change it, flip it. All right, so let me move this up a little bit. Make it a little smaller, maybe. Okay, so now we're going to have sine squared theta over cosine squared theta times cosine theta over cosine theta plus 1. Looks like we're getting close to what we have on the right side. This cancels. And we have, with one of those, so we have sine squared over cosine times cosine theta plus 1 on the bottom. So sine squared over cosine becomes, sine over cosine is tangent, so we could write this as sine theta tangent theta over 1 plus cosine theta, which is what we got over here. Now that's probably not the only way that that could be worked, but that's one way that it can be worked. We worked with both sides till we could get both sides saying the same thing. But notice I never crossed that line. You work with the left or the right or both independently, but this is not an equation to solve. After the Iowa test, we can stop taking computation quizzes. Okay, on page, your assignment is on page 385. And that's 33 to 45 every third, 61 to 63, and 71 and 72. I think 61 and 63, no, that's not I was thinking it was. No, it's not on the calculator. Okay, so after your quiz, I want you to begin work on this, and you'll have time to do a good bit of it in class.